foot or two. So that's the way you effect repair there. If there's something burned out here or in here you don't want to repair, then what I recommend that you do is go ahead and clip the cord off, and I'll show you how to make a little adapter so that you can use a standard off-the-shelf AC adapter and you don't have to go back to Nintendo. So replace the strain relief, and then you can put the lid back on to the AC adapter, and at that point you'll want to plug this in and test it, and then you can go ahead and secure those screws with the modified needle nose and return it to the customer. Right now I'm going to show you how to make the adapter. Repair the inside of the AC adapter. What I'm going to show you how to do is how to make an adapter on the Super Nintendo. Normally this is the most cost-effective method, and this way you'll get repeat customers that'll come back to you for the AC adapter. What I recommend that you do is first take the AC adapter and take this old cord and clip it off somewhere about a foot or so from the adapter. Then take this, and you won't need this anymore, so you set it aside. Okay? Now you've got the end. This is the valuable part. This is the part that you want to keep. What I recommend that you do is take a standard RCA plug, and what I like to do is I like to take the male end of it and mate with the male end of this, and I'll show you the reason for doing that. What you want to do is you want to strip this back far enough to expose the shield, and then you want this inner green the inside green lead, insulated green lead, has to fit inside the point of the RCA jack. So then I strip it back a ways, and this inserts. I like to group the end. This will insert on the center and protrude out the end a little. I don't know if you can see that or not. Okay, so that protrudes a little. I'm going to have to grab the solder here. Okay. So that protrudes a little. Now you want to take some solder, heat up your soldering iron, and you'll want to solder that end. Okay? So now that you've soldered that end, go ahead and clip the end of that, and you've got this part here now. What I do is I wrap it on the inside like that. Wrap it on the inside, wrap it once around, and then loop it through the inside. Okay? Then I take the solder and I solder it to the base to give it a good solid connection like that, and then I clip the remaining off and throw that away, and then you can clip this down as a strain relief. So essentially that's what you've got now. You've got a male end on the other end of the unique Nintendo. Okay, what that creates is it creates a little adapter. Okay, now what I like to do is I went out and I bought a standard. Here I have a standard, just a generic transformer that meets the spec of the original Super. You want to look for a 12 volt DC with about a 1 amp output. Okay, this one had a connector on the end, which I just cut it off. Okay, you want to make sure that you follow. If you take the old Nintendo take the old Super Nintendo embossing, and you'll see that the outer portion of it is positive. So what you want to do is you want to strip these back and make sure you know which end of this is positive. Okay, and the idea is to now put the female end on this end, which will mate with the male end here, and that will then give you a transformer that will work on the Super Nintendo, and they can come back to you for replacements should it break, because it has this. You've now made this adapter, which will work in the future. Now the reason I put the female end on the end of the transformer is, if you'll notice on the back of the Super Nintendo, there is an RCA jack here, and you don't want to put the male RCA on the end of the transformer, because if the male RCA is here, inevitably the customer will attempt to plug it in here and you'll get damaged. So if this is a female and that's a female, they can't plug it in and damage the Super Nintendo. If they plug this in like this, since there's no power to this, obviously it can't hurt it. So you want to let them know that, and that way it kind of dummy proofs the Super Nintendo and the adapter that you've made, so that they can't hurt it. They can't mess it up. All right. So now we're going to unplug that, set this back down here, and I'm going to switch you back to the adapter for the Super Nintendo. So determine now which one of these is positive. Go ahead and plug it in. Get your voltmeter, put it on. You want DC volts, and determine which one's positive. And it turns out that the one with the white line is positive. Okay, so to match with the embossing, I want the positive to go to the outside. Okay, so here's the outside. We'll go back to ohms. The outside happens to be the shield. The shielded part is the outside, and that's the one we want to be positive. We want to be plus. So what you'll do is you'll take the unstriped one and solder it to the center, and the striped one will now go to the outside, where it can now transfer the positive end to the Super Nintendo. So I'm going to go ahead and strip that back a little ways. I'm going to go ahead and tin the ends. Okay. You, of course, could probably have done a lot of soldering and won't need much of this, but we're going to hold that in place. Solder the one connector in place. Loop it over and solder the second one in place. Okay, using needle nose you can crimp that down and make a strain relief. Doesn't pull out. Okay. Now check to make sure it's not going to short out if it's moved around. You may want to even use some shrink tubing if necessary. So now I have the female hooked onto here. Attach the male to the other end. I'm going to join them, and then I'm going to plug this in. Move this to DC volts. Plus should be on the outside again, and sure enough, 16 volts. So now I have an AC adapter, and when plugged into the Super Nintendo and turned on, will give me a light. And that's what you'll want to do in most of the cases. The reason for that is, now in the future you've now given the customer the liberty of going anywhere in the country and getting an AC adapter. And they may want to bring it back to you to put the female RCA jack on the end. But that you've now one of the last things we need to talk about is the Super Nintendo controller. And basically there's three major components to this. There's the cord, the printed circuit board, and then the casing and the buttons that go with the casing. The cord is a non-standard 7-pin adapter, and it's linear and fits into the front, obviously. Now you'll get some of these in where this plastic is broken off, and they can go ahead and use them. We're going to try to get some cables in, and we will have replacement cables, so check with us on the pricing. So if the cable's broken or cut somewhere, you may be able to just repair it. In some cases you'll need to replace it. Okay? This cable is, the connector is the same as the connector that fits on the Japanese version, incidentally. There are 5 screws that need to be removed to get access to the inside. And I'm going to go ahead and put the towel down so we don't scratch up the connector cover. These are just standard Phillips screws that you don't need a special tool to get into this. Back comes off, and this is a little tricky now. In addition to the options on the top, you have up, down, right, left, select, start, A, B, X, and Y. You have a left and a right up at the top, and there's a little lever and an axle that fits in there. And you want to be careful. I've had some people take these apart and try to repair them, and they've lost that. So you may want to be careful. The cord comes off by simply pulling it out and around the strain relief that's in there, and then unplugging it. And you can unplug it by rocking this piece back and forth, and it'll come right out of the plug. Okay? Now this is what the cord looks like. There's 2 little circuit boards that are attached via 2 small wires, and those can get rocked back and forth, and those wires can break, so you want to be careful on that. What you want to check is check the circuit board to see if there's any dirt, and remove any dirt that's on there. And then make sure that the silicone inserts are removed, and the top will just, the rest of the pieces will fall right out. You may want to take this piece and this piece, these 2 pieces, immerse them in water with the 2 buttons, and wash them thoroughly. What I like to do, take some warm water with dishwashing liquid, immerse these in water, and then scrub them down with maybe a toothbrush or with a large necessary. This one doesn't need it, but you can do that if you want. Okay, we'll set those aside. You want to check these membranes to make sure that they're not torn. Look around to see if they're torn. If they're torn, they need to be replaced. Okay, and there's replacement kits you can get from us that fit in here that will cover. You'll get the whole membrane, all 3 membranes, with the kit. Okay. Now the one thing you want to learn is the circuit board itself. There's actually 2 versions of the circuit board out there. This version has a single chip in it, and what it does is it really incorporates this is a 16-bit, a 16-stage shift register. Another one that you might remove and look at has 2 chips here, and those are 8-stage or 8-bit, 8-stage shift registers. They're identical. This one right here happens to be 16-bit. The others are identical to the chip that was in the original Nintendo controller. If you looked in the NES controller, it had a chip in there that was a CMOS chip, a CD4021, and that was an 8-bit shift register. It had 3 outputs on it, Q6, Q7, and Q8. What they did was they eliminated Q6 and Q7, so there's only a Q8, and by doing so they eliminated 2 pins and were able to combine that into a 14-pin surface mount, which is what you see on the version with 2 chips. This happens to be have more pins than that, more than 14 pins, because it incorporates all of the functions. There's actually 12 functions that it has to monitor: up, down, right, left, select, start, A, B, X, Y, and then left and right. So it needs all 12. The easiest thing to do on this is, at this point, we're trying to find a source for these chips, an alternate source. Nintendo went, and because they're large enough, they created their own company to make chips. Mitsumi actually is working with Nintendo to make this chip and to make the circuit board. So this is a Mitsumi chip, and they make actually 2 versions of it, as I mentioned. If this is bad, and this can go bad and will go bad if the customer has inserted or unplugged. If the customer inserts or unplugs the joystick while power's on, you can damage this chip. So they need to be careful with that and warn them not to do that. If you get some in that are damaged, most of the ones that you get in are damaged because of mechanical reasons, something mechanical. They've jerked on the cord, and what's happened, as you see in this case, is these strain reliefs break. The cord then is able to pull straight out, and it comes unplugged from the circuit board. So what you can do in a case like that is simply super glue back the standoffs or the strain relief, reconnect the connector, and hook it back and charge a fee that's appropriate. If you have determined that it is this chip located on the circuit board, you can circuit board to us, and we will swap them out to you. Again, check our price list for the fee on that. And in the future, we will try to secure a supply of these chips so that we can supply them to you should you need to. But at this point, probably the best thing you can do is swap these out and clean them off if they're dirty, and get them back. So most of the problems that you'll get that I've seen so far with the Super Nintendo have been the mechanical, dirt or pop or something spilt down in them, and so you'll just need to clean those off. So what I'm going to do is I'm going to show you how to take this connector off, shorten the cord, and then that will show you how to cure most of the problems with the controller. So what I like to do, the first thing I like to do when I do that is plug the cord back in. Okay? And then grab a piece of paper and record the color order of the controller. Again, it was white, orange, red, and brown. Okay? In that order. Unplug this. You'll need some solder wick, as we've showed you before. Take the solder wick, and just unsolder one side. Sometimes you may have to just do it on both sides when you're sure that they're free. Okay. You can now rock the connector back and forth, and it should slide right out. Okay, now those are fairly small holes. Fairly small holes. And you may even want to write on the circuit board here which side was white. So I'll write white on this side so we know exactly which side it was. White goes on the longer side, brown goes on the shorter side, just in case you're wondering. Okay, so that can be removed. Now let's pretend that somewhere in here or down the way there's a bite, a cut, a break. Again, if the customer takes it and wraps this around the controller, a sharp bend occurs right here, and it will break right there. So what I'm going to do is I'm going to take this, pretend like the bite is somewhere in here. We want to go down from the bite, obviously. And then what you want to do is you want to strip this back far enough so that you have access to the wires. Now there's a rope enforcement in here. There's some rope in here, some string, and all that does is add enforcement to this, so when they pull on it, it won't break. So then take your wires, strip them off, appropriate length. Okay. Take your printed circuit board. What I do first is take the I like to tin them first. Take the solder and just tin them so that it adds some rigidity to the end, so that they'll go through the holes a little better. And then just follow your diagram. So you insert the white first. If you get too much solder on when you do the tinning, it won't slide through that hole. You've got to be kind of careful. So slide the white through, and then solder it. Okay. Then yellow goes next. Sometimes if you get too much solder on, just adding a little heat to it will fix it. Okay? And so on. Work your way down. White, yellow, orange, red, and brown. And once that's there, you can secure the, clip off the ends. We're going to pause the video here, and then I'm going to go ahead and complete this and show you what to do when it's finished. Are soldered in there. Clip off the end. Take your top portion, and what I like to do is what I like to do at this point is take the top portion, and you can take a little super glue, and usually these standoffs, when they break, they break off in such a way that they're easily glued back. Into the top. Okay? So glue the standoffs, apply the super glue, and didn't put enough on that one. And then set that aside to dry. I usually do that while I'm soldering these. So now that that's soldered back together, you've now again gone around Nintendo. Nintendo made this so that their world-class service center people could get a cord, and within just a few minutes, they can unscrew the old controller, pop out the old cord, and pop a new one in, and repair it. Unfortunately, if you don't have access to it, if you don't have access to these cords with the connector on the end, then it becomes a problem. So what we've done is just avoided having the need again to go to Nintendo. You can keep doing that and shortening that and making it shorter and shorter as long as you need to. To put this back together again, you'll note that embossed on the inside, they have the colors are mentioned purple. So you take the real light lavender ones, and they get one with a little niche at 90 degrees. That one has to go in the top one. Then there's a lavender one with a niche at about 45 degrees. It goes in there. Then there's a purple one with a notch at 45 degrees. It's about 60 degrees, I guess. It goes in there. And then there's one here with a notch at about 20 degrees, and it goes in here. So they've made it so you can't get these interchanged because there's a different depth needed to maintain the button size at the top. And so they've got a little niche at different sizes that you need to be aware of when you put that back together again. And then the center two buttons here, this piece of silicon goes there. You have the button that goes there with fits like that. Okay. And then this one fits on just like that. So that's how those go, and that can be laid down there. Now the tricky part, as I mentioned earlier, are the side buttons and their associated silicon membrane that goes on there. Those slide down right in here like this. Okay. Now what you have to do at this point is take the circuit board and put the circuit board back on, making sure that this is a little tricky. Make sure that these two little subboards are pushed down in all the way. Sometimes they'll stick up like that, and you can work with it to get the top back on, but if when you do, it won't fit right. I mean, it won't work right. When you get the top back on and the customer gets it home, these two buttons won't work, and that's because you haven't got these two little subboards down in properly. So push those down in all the way like that. Then embossed in the top right here, you have an R and an L, and that corresponds to the L and the R of this. So what you want to do at this point is, and I'm not sure if the glue's hard enough on here, so this might break off again, and it just did. So what I'm going to do is pull these for demonstration purposes. For the purpose of the video, I won't do that. I'll just run it straight through like that. So what you want to do, and you want to mount that, go ahead and mount that in like that. Then take the right, put its pin, corresponding pin and axle, and put that one in. And you want to, at this point, make sure that these two boards are pushed down again and that indexes properly. Then, on one that's not broken, you want to make sure that this cord is wrapped around the strain relief, and it'll wrap around there and come out here. Now, in this case, what I'm going to do, we're going to pause here for a second. Strain relief pins broke off, and I didn't choose to glue them back on. I glued them on, but they broke off again. what I'm going to do is I'm going to put one of these little nylon ties on. And what I do is I estimate and give it a little bit of slack. Okay? Put the nylon tie on like so, right about where you want the strain relief to be, and then you can pull it tight, pull it real tight like that, and then that will effectively be your strain relief. So if those pins break off and you don't want to glue them back on, like I did, you know, like I'm doing here, and you don't want to do that, you can hook this nylon tie wrap on and get a pair of needle nose and make sure that's tight enough that it's going to give you the strain relief that you need. Clip off the excess and fit it back down through the hole. You can rotate it down in and it'll fit right down in there, right between the circuit board and the outside, and that gives you the strain relief that you need. Make sure the two boards are back down in because they work their way up if you move the board around too much. Okay? And in that position now, you can now take the top and reinsert the top. A little tricky to get it back to go on just right. Okay. Reinsert the top like that. Now you have a strain relief, and if they pull on it, it's not going to hurt anything in there. And go ahead and take your 5 screws, replace your 5 screws. What I actually like to do at this point is replace these 3 right here. And then I test the controller to make sure everything is alright. I go ahead and hook it up and run it on the video, on a game, one of the video games. Make sure everything is alright. So secure the two, either these 3 screws or these 2, whichever you want to do, and then plug it in and make sure everything tests all right. Once you plugged it in and made sure everything tests all right, then replace the remaining screws, and you've effected repair on the Super Nintendo controller.